Okay, here we go. Am I live? All right, good morning. Obviously the pandemic is still on, so we are not safe. Am I live? All right, good morning. Obviously the pandemic is still on, so we are not safe. Am I live? There we are. Right. So the pandemic isn't safe yet, so obviously we're not back in the schools yet, so we're still going to be sticking with online stuff. I'm not sure exactly what we're going to be teaching this semester. I never do know, so I just kind of make it up as I go along. So today I'm going to start off with a bit of FreeCAD, which we've talked about before, and but we've got new students in, so let's see how that goes. If you look down, let me just bring this window over here and move me out of the way. So in YouTube you can see that down here there is a little chat box. If you have any questions or if you want to introduce yourself, that's where you do it. And I will answer any questions, almost any questions. Just try and keep them slightly on topic. Okay, so today I want to talk about lithophanes and how we can design frames for them. So first off, what is a lithophane? Well, let me just show you something here. Do I have any? No, I don't. I just still have it in the frame. This is a lithophane, okay? Doesn't look like much, okay? You look at it, it doesn't look like much. Okay? Now, let me just show you something. So I've made this frame, and if I just attach a battery to that, now I haven't made this easy for myself, so let's just see if I get it right. Let's see, put that in there. Yep, and that in there. Nope, I have it upside down. So put that in there. Yep, and that in there. Whoa, blind myself. So now we have a light box. Okay, if I hold it closer, you can see there's actually only 4 LEDs, 6 LEDs, but they're very, very bright. So what happens when this goes in front of this is interesting. You end up with a nice, bright photograph. But it's 3D printed. It's a 3D printed photograph. Now, do we have anyone who's online? Just put your name into the comment box so I can see who's there. Gangster YF says hello. That's one. Okay. So I had to hold this a certain distance from the lights in order to have the picture looking clear. So today I'm going to, so I need to obviously redesign this. So I thought I might as well redesign it with yourselves, just to show you exactly how I would do this. This is something that's useful. Well, it's cosmetic, but let's call it useful. It's something that we can make, and if you guys come up with your own 3D designs, I can print them because I still have all these printers. So today we're going to talk about how to use Andrew is Gangster JF. Okay. Today we're going to talk about how to use one form of 3D design called constructive solid geometry. So constructive solid geometry, we'll just move that out of the way, is where you take, you look at a design. So let's say I'm looking at this. Now let's look at the gold part, the frame. What is this shape? It looks like a rectangle, and it kind of is, but it's a rectangle with 4 circular holes, and there's a big rectangular hole here and another different sized rectangular hole on the front. So if you can break that down into the shapes that you're pulling out of the solid rectangle that it starts with, then that is constructive solid geometry. So let's do that. So first off, we're going to need something called FreeCAD. CAD is short for computer aided design, and it's basically design using computers. FreeCAD is a free program for doing that kind of stuff. Let's have a look at what I have here. So before I install it there, I'm sure a lot of you don't have it installed. So let's go look for that. I think the website is freecadweb.com. So if I just open up the browser here, run the search for FreeCAD. And there you go, freecadweb.org. So you would go on to that and click on download now, and then download for whatever your computer is. There's no need to do it right now because it is quite large, and I don't know what your broadband is like, and we don't want to get through the messiness of installing it during a live demonstration. So download that later on. You can always watch back on this. Once we're finished with this stream, you can then watch it back later. So I'm gonna just keep this open so I can see what people are saying. Feel free to ask questions. Ask as many questions as you want. Okay, so let's assume that you have it installed. So I've got it installed. Just open it here, and I'm going to make this little picture here smaller. Yoink. So I can make this bigger. We'll just close that. It's not interesting. It always opens up with that screen. It's just messy. It doesn't mean anything. We're going to create a blank document. Okay. Now let's go back to this. So first thing you want to know is the size of the photograph that you're going to be putting into this. All right. We'll talk. We can create lithographs, lithophanes. This is what this is called. The 3D printed photographs called a lithophane. And we can. I can do that. Pretty much any photograph given to me, I can convert it into a lithophane. So if you guys come up with your own frames, I can print the frame and the lithophane that it's for. So first off, we need to know the size of the photo. And in this case, it is 120 millimeters by 76 millimeters. 120 by 76. So let's just create a rectangle. So we'll go into, now this gives you different consoles, which have a lot of different different toolbars from which you can select various tools. So the one we're interested in right now is part. All right, part is what you'll mostly be using when you're doing constructive solid geometry, CSG. And it includes all these solids and then various things you can do to the solids. So we're going to start off with this cube-ish thing. It says cube, but it starts off with a cube, but it ends up being a cuboid. So using the mouse, if you use the middle, so I'm pressing shift at the same time as using my right mouse button, and that lets me drag things around to view it in different ways. Okay, so if I click on that, you can see it gets selected over here as well, and that gives us different things down here. So we've got the dimensions of the box. So we've got the length, width, and height. Now I'm going to say that the length is 120 millimeters, and you can see that that gets updated over here. So I can now scroll back using the mouse scroll, and if I use control and right mouse, I can move things left and right. You get used to the mouse controls very quickly. Okay, so 120 wide, sorry, in length, and I'm going to say that the height is, was it 76? I think it was 76. Okay, now why does it do that? It doesn't look like a height to me. Well, if I just move myself out of the way, you can see that we are actually viewing it from the top. So if I just view it from the front, so I've just used the shift button and the right mouse button, and then I can do that. Scroll out again, and I've got it nicely in view from the front. Okay, so that's the photo. Now there is one thing as well. That's a very thick photo. So let's have a look at that again. It's in the frame. I've glued it in. I can't take it out. I'm thinking it was about 2 millimeters total. So let's just change the width to 2 millimeters. Now, if you look at this, what the view that we're looking at here is orthographic, which means that it's not perspective. So it's not like we're using a radial view and we can see outwards at a certain degree of view. Instead, we're using orthographic, which is as if our camera view is a certain width and we're just viewing straight ahead. Now, you can change that if you want. So view perspective, and you can see that that's more like what you would see in real life. If I scroll it up and down, you can see it's actually as if it was in real life. It doesn't really matter. You kind of get used to both views. This thing always starts off in an orthographic view, but you know, some people might find it easier to view it in perspective, give them a better idea of what they're looking at. So let's pretend that that is the photograph that we're looking at, and I'm going to color that white because it's white in reality here. So if I click on the cube again, click on view, then we can change the shape color. So you can select the color here, and I'm just going to choose that looks white. Red, green and blue is all 255, which would be the maximum numbers for them. Click OK, and you can see, well, there's not much of a difference, but it's white. Okay, now, so by the way, if you think of a topic for next week, or you get bored of this and you think like, I don't want to know this, I want to know something else, tell me, you know. So the next step is we start on the frame itself. So let's work on that. Now, when I built the original, I leapt straight into what's it called? Dynamic? I can't remember the word for it. A method of just telling the thing it's 120 by 76, and then it was able to calculate the rest. Right? We're not going to leap into that because it's a lot of work. But what we will do is we'll build the frame first, and then we'll retrofit this dynamic stuff into it. So first off, we're going to build another box. So there's a box there, and we're going to make this bigger than that. How much bigger? Well, that's the question. Okay, so we'll start off something simple. Let's say it's 10 millimeters, so about that big. 10 millimeters bigger than this. So first we need to move it. There are a number of different ways of moving an object in FreeCAD. Okay, because we know exactly how much we want to move it, I'm actually going to tell it. So go into placement, and we're going to use position and change the X. So if you just use the up and down arrows, you can see that it actually moves specific increments of 1 millimeter at a time. And I'm moving it 10 millimeters. 10 millimeters in X, which would be left and right, and then Z should be up and down. And that's 10. And if we zoom in on that, you can see it's exactly at the edge. Okay. Now, we make this bigger than the frame, and it's going to be 10 millimeters of margin around the entire frame. So obviously it's going to be 10 plus the photo width plus another 10. Now there's something we're missing here, which is margin. I'm not going to worry about that right now. We'll actually get back to that when we're doing a bit more dynamic stuff. So right now I'm just going to demonstrate how to do this very simply, and then we'll make it slightly more advanced. Okay, how to emulate different software would be cool. What kind of software would you want to emulate? And by emulate, do you mean that you want to rebuild it? You want to build your own version of it? That would be interesting. You know, if you, like, I was actually thinking like it'd be interesting to do a Minecraft clone. That's a pretty advanced thing to do, but you know, we could do that. Let's see, cube. So the length is going to be 10 multiplied by 2 plus 120, which is 140. And then the height is going to be 10 multiplied by 2 plus 76, which would be 96. And there you go. And if we look at the other side of it, so I'll just move it around, you can see that the photograph itself is invisible. That's because this has a width of 10 millimeters, whereas the photograph has a width of 2. Now look at that. When I was moving that, you can see that the photo is kind of coming into and out of view. Why is that? Well, that's happening because the software is trying to figure out what is it going to show at every single part of the screen. So it tries to do some calculations to figure out what is nearest to us. But the thing is, because this is so mathematically exact, the photograph and the frame are actually exactly the same distance from each other from the screen. So it doesn't know which to show. So it's just showing one or the other, kind of almost randomly. Now, I'm going to now delete the photograph from this box. Okay, so first off, I don't know which is which. I don't remember. So we're going to change the labels. Now, width 2mm, so we're going to label this photograph. Oops, put it in the wrong place. We're going to label this, click in there, photograph. Okay, now it's more obvious. So that's the photograph. And you can see actually as I select things, in here, the selected objects are kind of highlighted. So you get a green outline and the colors shift a little. Okay, and then we're going to call the outer one the frame itself. So the outer one we'll call frame. Okay, so we have the frame and we have the photograph. Right, so I'm going to now delete the frame from the photograph. So we select the photograph, the frame first, and then control click on the photograph to also select it. But the order that you select things is very important here, because you're deleting the second thing from the first. And then we'll go up here and look at these little mathematical things here. Okay, and that one there is make a cut of two shapes. So now I've cut that out, and if we zoom in and do a little bit of movement around, you can see that there is an indent shape. Okay, now the next stage is that we need another hole here that the photograph will then poke through. Now I just want to show you something here on this original. So if we look at this side here, you can see that the cutout that I have here is a certain size, and it's more obvious now if you look at the width of the side here. And I'll turn it around, and the width is very slightly smaller. It's 1mm smaller. Okay, that's because I have the photograph in, and I don't want it pushing through. So we've got a little bit of a kind of a margin around it, kind of a lip to stop the photograph from falling out the front. And you'll see that in all photo frames. The photograph itself, almost all photo frames, the photograph itself is generally slightly larger than the hole on the front of the frame that you can see the photograph through. So I've wanted to reconstruct different software or modify different games. Modifying is not the same as rebuilding. Now it would be interesting. This is it's an interesting topic. It's reinventing the wheel, but people say don't reinvent the wheel. I disagree with that. I think that in software, when you're learning to build software or learning to build programs, reinventing the wheel is very, very important. If you have never, for example, written the traveling salesman program, if you've never written the traveling salesman algorithm, then you don't understand what's going on when you're running it, and you don't know why this one is better than that other one, which might be like the ant colony algorithm, or simulated annealing, or other versions of the same solution, other things that solve the same problem. When you're like to reconstruct different software, Doom, for example, the original 1990s game Doom, the software in that is very, very simple, but I can almost guarantee you that the guy that wrote Minecraft started off by thinking it'd be interesting to write a clone of Doom, and then just it grew. But I can nearly guarantee you that. I think that it's a very good idea to reconstruct software and do things. In fact, I'll give you an example. There was back in about 20 years ago, there's a program that's now called CK Editor. Back then it was called FCK Editor, and I'll leave it to your imagination to figure out why they changed that. But it's basically a program for helping to design HTML within a web page, or writing stuff within a web page that might include images, bold text, etc., 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 without having to write the HTML itself. Okay, but it needed a file manager. A file manager is basically a way of uploading an image, or uploading some software, or uploading a program, or a file, or whatever, and linking to it so that you can show that on a web page, that you can provide a link to that. Instead of using programs like FTP or SFTP or ORSync or other things to upload the file and then trying to remember, like, what was the URL of that. So you use a file manager. It had a very, very simple file manager where you could upload a file, but it was kind of ugly and you couldn't delete it, you couldn't rename files, you couldn't, it fell down in a lot of ways. So I actually built a file manager for it. And it was called KFM, and it's actually still available online. K's File Manager, even though I haven't touched it in 10 or 15 years, and I really recommend that people don't. Yeah, that's still available online, K's File Manager, and you can actually, I don't know, you could hack it if you want. It's available online, but it taught me a lot, and by building it, I was actually able to enhance what was already available elsewhere, and then other people came along and they built better ones, better file managers, to beat what I'd done, and then other people built things that beat what they'd done. And so the reason that we have so many great pieces of software out there is because of people like yourself that want to take existing software and rebuild it and make it better. In fact, you're probably looking at the internet through Chrome. Chrome is built on WebKit. WebKit is a Linux program that was built for GNOME. Was it GNOME? I think it was GNOME. And it's basically a rebuild of other software. Like it was there was no point people just saying like, oh, we have a web browser, it's called Mosaic, we're done. Other people come along. Firefox, was originally a Netscape Navigator. They would build their own browser because they think, well, I want to be able to, flash things on the screen, so let's do that. In fact, Netscape's big enhancement was JavaScript. They invented JavaScript. They called it ECMA script. It's not very catchy. Right, back to this. So we need a hole at the front for the frame to look through, and so you can see the photograph. Let's make the photograph visible again. So we're using the photograph here as a template to cut out, but we also need a copy of the photograph itself so we can see what's going on. So I can just copy that, or Control C, and we can just paste it. So edit, paste, which you can see is Control V. So it's very useful to know the key bindings, so you can just very quickly do things. So now we're back to what looks like the original, except look, if I now move this around, the little flickering is gone. Okay, that's because we are now definite that this is the closest thing to us. That photograph 001 is the thing that's closest to us. All right, let's make a hole in the front of the frame now to fit that in. So I'm going to hide the frame. So you can see, actually, we've got frame here, and we've got now cut here. So if I close that, you can see it's now, we don't know what it is anymore. So I'm going to rename this frame to frame block. And that will then let us rename cuts to frame. Okay. You see we've got photograph and photograph 001. I'll call this photograph cutout, which will then let me rename this to photograph. Okay. Now, so I want to take a copy of this photograph and make a very slightly smaller one that we can then extend outwards and use it as a cutout for the front of the frame. So I'm going to hide the frame first, so we just have the photograph, and I'm going to copy it. Copy, paste, Control C, Control V, and I want to actually extend it outwards in that direction. I don't remember what direction that is. I think it is Y. So there's the width, 2 millimeters. If I now make that bigger, you can see there, yeah, that gets bigger. So I'll just move it first. I'm going to move it very slightly in Y, 2 millimeters. So we now have two copies of the photograph right next to each other. When you create a box or anything like this, it always starts off as being 10 millimeters. So that's actually the width of our frame, 10 millimeters. In fact, you can look at that and see that, well, it's made of these things. Frame block is 10 millimeters wide. So we want this to be 10 minus this 2 here, which would be 8 millimeters. 8. Okay. But obviously it's too big because it's the exact size of the photograph, and if you have a hole at the front of the frame that's that big, the photograph's just going to fall right through. So we'll make it smaller. So lengthwise, let's cut off 2 millimeters. And the same with the height, we'll cut it off by 2 millimeters. Okay, and that means we now have to move it in X and Z. So in placement, position, X, we will just add 1, and Z, we will add 1. So that's actually the shape that we will cut out of the frame. Now, there's a little issue that we have here, which is that I can't just add that into here. I can try, but you can see the little symbol that we have, which is kind of a don't go here thing. I can't just add that in there. Can't add it, it doesn't go. So what I'm going to do now is I'm actually going to copy these out again and do it again. I'm going to do the cut again, but I'll do something else first. We'll just hide that photograph and unhide this, the cutout. So that's the cutout, the original cutout. And I'm just going to rename it to cutout. And this is our inset, I suppose you'll call it. So I'll call that inset. And we want these two to be joined together. Those are the important words. We want them joined together so that we can cut them out of the frame. So we'll use this, which is a join. Make a union of several shapes. Union is the mathematical term for what we're doing. So now we have a fusion or union or join. Different words, different. I don't know why they just don't use the same word everywhere. Okay, so now I'm going to call this holes, because that's kind of what it is. And then this is the frame block, and we're just going to cut the holes out of the frame. Now we see we're back to the flickering, because everything's exactly the same size. So I'm going to cut it out of the frame block. Just rename that to frame block first. And we'll cut out the holes. Gone. Now look. So if I look at there, you can see that there's a little lip. And that's where the photograph goes. So the photograph can sit in that, and it won't push forward out of the frame. Okay. Now, the way, obviously you could push it the other way. But the way I stop that is I literally put some glue in it. Because this is 3D printed, I don't mind 3D printing it again if I get something wrong. Also, I'm never going to be changing this, because each photograph frame that I build with these Lithophanes is going to be a slightly different size depending on the photograph size. So I'll have to print a different frame every time. And that's where we get to dynamic sizing. So if I have to make a frame every single time I make a new Lithophane, that's going to take a lot of time. It would be very, very useful to be able to just tell the software, FreeCAD software, the photograph is this big, make a frame. So let's do that. Okay, Do you have any questions so far? I mean, this is kind of the basics of what CSG is about, constructive solid geometry. You know, this literally can be 3D printed right now. I mean, I can just take that object, export it into STL format, and then print it using a printer. This, like, it's just straight there, done. We can print that. It's very, very useful. Any questions before I get on to the next part? You type questions, I'll carry on as if there are none. One thing I am missing is screw holes. So if we look at this again, on the front I do not, where's my camera? There. On the front I don't have any screw holes. On the back I do. And the reason for that is because I want to be able to screw that on. I mean, I could glue it on, but you know, this is a prototype, and I want to be able to, like, if an LED burns out or something, then I can just replace the LED. So we have screw holes. Right. Nope. Okay, let's get on with this then. So to make this dynamic, we're going to use a spreadsheet. Now, it's not as scary as it sounds. A spreadsheet is literally just a grid of numbers. So we're going to go into spreadsheet. Now, first, before I do this, this is our toolbar list. Okay, it's got a lot of stuff, and there's actually a lot more available to do things with. But you know, if I click on part and change it to spreadsheet, you see that changes. So we now have other stuff here. In the spreadsheet one, I'm going to create a spreadsheet, and you see that creates that. And that's everything that we're going to use with this toolbar for. We can go back to part now. We now have this spreadsheet. If I double click on that, you see it opens a new tab. So we had the original and we have this spreadsheet. Okay, now I'm actually going to change the view so that they're both visible at the same time, and I can do that with Windows. Let's say, well, I could use tile, I suppose. Yeah. Okay, so now we have everything visible at the same time, and I'm moving myself down here just to make things a bit easier. Just move this over. There we are. Oh, okay, let's try this again. Tile, there we are, better. Okay, let's make this dynamic. So first off, we need to know, we're going to want to put in the photo length. Now I'm going to call it photo underscore length, and we need to know the photo underscore height, because I'm going to be, I mean, you could say length and width, but they'll be vertical, so length, height, that's what I'm calling them. They're just words, you can call them whatever you want. Okay, so and we'll say that the photo length is 120 millimeters. I'm just going to write in the number 120, and you'll see why in a moment. And the photo height is 76, and just the number. Now I'll just make more space here so we can see, because that's really all we need. If we right click on that and click on properties, then go into display unit. Now we can say that the number here is actually in millimeters. And we're going to use this alias and call it photo underscore length. Alright. And I'm just trying to think how to explain this, but this cell is not actually linked to that cell. It doesn't mean the same. Like, just because it's beside it doesn't mean that the computer knows that this has to do with that. So you literally have to tell it that when you say photo length, that this number is actually what you mean, and it's in millimeters. So you can see that actually there's a space in there. So 120 up here. If I was to change that to, then you can see it's 12,023. Formatted very prettily. Okay, so we'll do the same thing with the 76. Change that display unit is millimeters, and the alias is photo_height. Okay. The only reason that we put in these two here, photo length and photo height, the only reason you type them in is that they are a reminder, a visual reminder to yourself of what those numbers are. I mean, they could be anywhere else. They don't really, they don't do anything, but they are just a visual reminder to yourself as a person filling in this. What is that 120? What is that 76? In fact, see there, gives you a nice tooltip. Now, so let's just change that to 60. I'm just going to cut them in half, 60 and 38. And we'll start making this dynamic. So to make this dynamic, let's have a look at that photo. That's the original photo that we just wanted to use to kind of, you know, as a visual representation of what is the end goal here. So that's the photograph. If we wanted that to be tied to what we have here, well then we go into the photograph and we look at the length here, and you can see that's where you type in that it will be 120 millimeters. But we have this thing here which is a function box. So we open that up, a formula editor, and we'll say start typing spreadsheet, just press down, and that gives us then photo, oh look, photo length. Result is 60 millimeters. So now that's 60 millimeters, and we can do the same with the height. Spreadsheet dot photo height, and that's the actual photograph size we want. So let's start changing everything. So if I go into, let's say, the frame block. Now we'll start off with the photograph cutout here. So the photograph cutout here, we've got it length 120. Again, spreadsheet dot photo length, and then spreadsheet dot photo height. I'm just going to hide this other one. You can see that we have this hole now, which is the size of the photograph. But this, like the inset hole, is wrong. So let's just change that inset hole. So that, now we get to the interesting part, because you can run formulas in this and directly in here. So the width of the box in this case, the 118 that we got here, we got that by taking the original width of the photograph and subtracting 2 from it. We'll do exactly the same thing again here. Spreadsheet dot photo, not the width, the length, photo length, and we'll subtract 2 from that, and you can see the result here is 58. And then we do exactly the same thing with the height. Spreadsheet dot height minus 2. Properly not, oh, that's because it's not height, it is photo height minus 2, and that gives us 36. And now if we look, you can see that's where you'd put your photograph, and you've got all this big inset here, and then you've got all this big waste here, and that's because the frame block is too big. So the frame block, we made photo length plus 20 millimeters. We'll just do exactly the same here. It's spreadsheet dot photo length plus 20, and the same with the height. Spreadsheet dot photo height plus 20. Okay, and let's just make the width of this. I'm just going to type it in as 4 millimeters. Oops. Wait, why didn't that work? Why? Sometimes you need to actually tell it recalculate. So there, it's recalculated. Okay, now you can see that looks very much like a photo frame. And what happens if we change the numbers here? So I've got 60 millimeters and 38 millimeters. If I change this to 65, you can see that the entire thing now changes. Change that one to 45. All right. Now that is very, very useful for what I want to do, which is I just want to be able to come in and say, look, I've got a photograph which is 120 millimeters by 76 millimeters, make a frame. And there's your frame. So you just put in the numbers and then you can export that out. Now, this is a very, very simple method that I've given you here. It's very, very simple. But that can be used to build up like robots or anything like that. You can build really, really complex things using that. You could say, like with a robot, you could say like, well, I want this wheel to be that big. And then it can recalculate gears and, you know, chain lengths and the size of the chassis and the location of everything based on what you have just done. Based on that tiny little single change you made, you can recalculate the entire build. Okay, so that's basically the outside shell of the photograph. Now, I want to be able to put screws into it. Now, let's have a look at what I did on this other one here. So with this other one, you can see I actually had more than 2 millimeter space. I've got it's a 2 millimeter lip here, which we have in our design here, but the photograph itself, I think I made about 4 millimeter space. So this could be, where's my ruler? Yeah, it's actually 3 millimeters. So this is about 5 millimeters in width. Doesn't really matter. But what it does allow is space to put bolt holes in there, so I can put a screw or a bolt into that. You need, like, when you're building these things, you need to consider what is going to connect into it, how is it going to connect, is there enough space? And that brings us to another problem. Okay. We have designed this to be very mathematically precise. If you have an image that is 120 by 76, then you must have a hole which is 120 by 76. But in reality, things don't work out like that. So, for example, when you're 3D printing something, you're talking about something which is liquid. You're pushing out a liquid which turns to a solid, and you're hoping that it's going to be precise. It's never precise. It's always a little bit off. So if we look at this, for example, there is a very small gap at the top, but there's no gap on the left and right. Okay, which means it's not as precise as we would like it to be. So we need to introduce a margin of error. Okay, so I'm going to create something now in the spreadsheet. I'll call it margin. Ugh, let's get rid of that caps lock key. Call it margin, and the margin is basically how much space we're going to allow for the fit of things. So just in case something doesn't quite fit. So I'll again go into here, change that to millimeters, and give it an alias of margin. Okay, and we'll call that. We'll say that the margin here is 0.5 millimeters. Oh, didn't need the mm there. So 0.5. Okay. If you put in 0.5 mm, it's actually going to cause a problem. So it just needs to be just numbers, nothing else, when you're typing it in. So 0.5 is correct, 0.5 mm is incorrect. It's confusing. That's the way they wrote it. In fact, if you feel like rebuilding some software, this would be nice. Okay, so let's introduce some margin. So what are we introducing the margin to? Let's say the margin is 3 millimeters, just so it's obvious to us when we do this. So we'll show the photograph first. So this is the photograph and the space that it goes into. And you can see that it fits absolutely perfectly into that space. But we also know that it is not going to fit perfectly in reality. Instead, it's actually going to be like slightly too big or slightly too small, who knows. So we will introduce a margin of 0.5 millimeters, which means that the space that this is going to go into needs to be very slightly bigger than the photograph itself. Alright, so let's have a look at that. So that means that this photograph cutout, which is basically a clone of this, needs to be very slightly larger than the original of the photograph. So let's just adjust this calculation. So we have spreadsheet.photo length, but we need to add not just the margin on the left side, but we also need the margin on the right side. So we need to add spreadsheet.margin and multiply it by 2. And yeah, there's a number of yeah, okay. Order of operations in maths is useful to know. If you don't know your order, like for example, see that's multiplied by 2. Some people don't understand that only applies to just this margin here. You're only multiplying this. You're not multiplying the rest. You're not multiplying everything. Some people don't get that. It's important to know your order of operations in maths. If you don't know your order, or if you're unsure about something, like for example, if I do that, what it gets done first, who knows? Well, then you can use parentheses around what you're doing, and then you can be sure this gets done first, then that, then that. All right, but I know that this is going to get done first, so the margin gets multiplied by 2, and then it gets added to the photo length, and that gives us 126 millimeters. And let's have a look at that. So now we can see that the photograph there has space around it of about 3 millimeters. There's space on one side. We might actually shift that a little bit in by the margin. Let's do that. So we go to photograph. So I applied it to the length, but I haven't done it to position yet. So go into placement, position. We can actually apply it to the position as well. So we say that this is that's in position 0, exactly 0. All right. Spreadsheet dot margin. So we'll just say it's at that. Now you can see that the photograph is on both sides here. That's the X. Now we also need to do Y as well. So let's have a look at the inset, the photograph cutout again, and we'll increase it by the height. So the height, we need to add the margin as well. Spreadsheet.margin multiplied by 2. Okay, I see we've got some new people watching. Well, one new person. So give me your names, everyone. Type it into the if we look at this again. If you want to talk to me, just put in a question in the chat. Okay? Feel free to ask anything. You know, everything's fine. Ask me anything. If you're lost, tell me. I'll go back. It's absolutely fine. So the height of the inset now, we're after making that space there. The height of the photograph, we've increased it to both sides. But it's starting to look weird, isn't it? Let's move that photograph up by that amount. So go into placement, position, Z. And we'll move that up by the margin as well. So now we can see that the photograph is in the exact center of the hole, but everything's wrong. Front looks okay, but everything's wrong. We can tell. So let's actually hide that. So I'll press space to hide that photograph, and you can see that we have a lot of problems here, and that's because we're applying the margin in just one place, but we need to apply it everywhere. So the margin needs to be applied, for example, to the width of the original block, so the frame block. The width of it, the length of it, sorry, needs to be spreadsheet.photo_length plus 20 plus spreadsheet.margin multiplied by 2. And you see that recalculates, and we see we have a space now here, which is the same as the space here. But we also need the space at the bottom to be equal to that at the top, and that would be height. So we'll just adjust the formula in there by adding the margin. Spreadsheet.margin multiplied by 2. Okay, so now that looks good. And all we have to fix, if you look at the front again, is that space there. So that space there, you can see that the one side is too big, and that's because the hole is not taking the margin into account. But we don't actually want the hole to be that size. The hole is actually fine, because we know that the hole is pretty much the size of the photograph minus 2 millimeters. We don't want to introduce margin to that, but we do want to reposition it. So the margin we are going to add, but we're going to add it to the position. So we'll go back to here and have a look at the whole of the inset. So if it just, a useful thing to know here is the space bar. If I press space, I can see things. Okay. Now if I change the placement of that, so we can see we have it as 1 millimeter. I'm going to just change the formula to that. So 1 millimeter, which was how much we moved it in by hand, which is fine. We're now going to add in the margin. So 1 millimeter plus so it's actually just 1 plus spreadsheet dot margin. That gives us 4. And you can see that looks correct. So now we just need to do the same with the Z. So it's 1 plus spreadsheet dot margin. Margin, there we are. And that's recalculated nicely. Okay, so let's unhide our photograph. Photograph sits there, but you can see the margin is very, very big. And now we can shrink down the margin so that it's actually more realistic, which would be more like 0.5 millimeters. That's more like it. See that? So you can see that there's a very faint space around the photograph, but if I zoom around to the other side, that space is not visible. Okay, so that's enough space for us to put in the photograph nice and comfortable and take it out if we need to. All right, and you will find that in pretty much every photo frame that you have. If the frame is for an A4 size photo, for example, or A5 or A6, then the gap that the photo goes into will be very, very slightly larger. Because if you don't make it very slightly larger, when you put the paper in, it may warp. So you'll end up with curves. For example, I've got a piece of paper here. Okay, that piece of paper is fine for that distance there. Now, if I was to make it the distance slightly smaller, you see it warps. The paper warps. And that's going to happen with your photographs, and you don't want that. So if you make the hole very slightly bigger, the paper is fine. There's no warpage. And then you have a lip at the front, so you can't even see that. It means you lose about 1 millimeter of the image because of the lip, but it's fine. Okay, so now that we have that, we can actually increase the size of the block maybe, and I'm not going to bother doing that. So we have the basics now of CSG, which is putting stuff together. Basically putting stuff together, pulling it apart. Usually you'll end up using just that and that, sometimes that. I have never used that. Okay, so just these 3 tools themselves are enough to do pretty much any shape that you can think of. Any shape at all. So that's a basic photo frame. Now, so let's talk about just simple manipulation of. Actually, I'm going to make the back of it as well. All right, so that'll introduce some more shapes. So let's say I'm just going to do it quickly. I'm just going to I'm going to make a new project and just create the back of the thing, which would include, if we look at what I've done for this, I've got holes to put LEDs in. I've got a hole in the back for wires to come out of. I'm not actually too happy with that, because that means that the electronics are actually inside, and there are reasons why I don't want to do that. So what I want to actually do for the next version of this is have holes at the side for the LEDs, where I have 6 LEDs, 1, 2, 3, 4, 5, 6, and I want the LEDs to come out and around to, this is the back, yeah, around to the back, and then we'll have the electronics at the back, and maybe I'll have another case that just sits right around the whole thing. Let's work on that, because that'll introduce another useful thing. Let's just do that. So I'll create a new document. I'm just going to hide these two. Let's save this first. Save as, and create a folder here called CoderDojo. We'll say this is photo frame front. Alright, and then I can close that, and we're left with this empty page. Right, so let's start again. We'll create a cube, and you can see we're in orthographic view, which is fine. And it generally starts you on the top here, so the top view. So I can move that now to the front, which is the way I like to see things. And then we'll start working on this. So the width of it, again, is going to be, let's say 140. And the height of it will be 98, which is 78 plus 20. Okay. And we'll say the width of it, I'm just going to change this view into perspective because I know people will be looking at it strangely. Okay. Now, so we need, I'm going to start off by just very quickly adding in a hole in this. I'll make this very slightly bigger first, so let's say 12 millimeters, yeah. And then I'm just going to create a copy of the cube, Control C, Control V, remember, copy and then paste. Okay, so Control C, Control V, and we'll make this smaller. And I'll make it smaller by 10 millimeters on all sides. And then move it into the middle. I'll change the width as well down to 10. And the width and the position I'm going to move to 10 by 10, which puts us in the middle. Can't see it from the back because I made it very slightly smaller. Let's make it bigger just so you can see. So that's 12, so they're both the same size. So if I make it very slightly bigger, you can see it starts poking out. But I want it to be just very slightly smaller. So that's 2 millimeters smaller. Now, if you were watching from the beginning, you'll see that I took this outer frame and I subtracted the inner box from it. But generally, the way I'd recommend that you take care of spaces is you actually put your spaces together all as kind of one thing and then subtract it all at once. So one thing I'm going to do here is I'm going to introduce a bolt hole right here. That you would put through from the back, and then it would eventually go through to the front of the frame and keep everything together. You might have it here, or you might have it, in fact I'll do it in the corner. I'll do it in the bottom left corner because that is the easiest to calculate, because if we're going to be changing formulas later on, that one will be easiest. So we'll use this cylinder. So the cylinder gets added, and anytime you add a new object, it's going to be added at position 0, 0, 0, which is this exact center, which, you know, that is basically the center of that world space. Okay, and then we want to change it so it's in its proper position. So you start off with it at 0, 0, 0, and then you'll change it. So first off, that cylinder is pointing in the wrong direction. So here's where we learn a little bit more how to change that. Now you could change it manually by going into the angle, let's say change that to 90, and then choose which axis that gets applied to and by how much. Or we could do this, right click on cylinder and click on transform, and that gives us this handy little thing here that lets you change things just by dragging. So I'm just changing the view so it's sideways, and then I'm just going to drag this red ball down until it's 90 degrees and let it go. And that looks good, so I'll click OK. And that's exactly where I want that. Well, it's exactly the direction that I want it pointing. Now I can change the position of it. The radius, 2 millimeters. That's when you're building something, you've got to keep in mind what are you going to be using to put everything together. So if it's a 2 millimeter hole here, that's an awkward size because 2 multiplied by 2 is 4 millimeters, so the hole is going to be 4 millimeter, which means you're going to be using like an M4.5 bolt. Okay, because you need to keep in mind. All right, I'll just show you. Just a moment there, I'll grab a couple of bolts. Oh, there's some M4s. All right, I've got some M4 bolts here. So if we look at a bolt, okay, the let's just look a bit. I'll make this screen a bit bigger. Hello. So, right, a bolt is made of a few different dimensions. Okay, we have the length of it, which you measure from this end to just before the head begins. And then you've got the width of it, which is actually two different measurements. You've got the outer width, which would be the outside thread, where would the outside thread end, which in this case is 4 millimeters. And then you've got the inner width, which I actually don't know. It could be 3.5. I don't know. But that's because that's not important to me. What's important when you're talking about threads, yeah, it's 4 on the outside and it's about 3.5 on the inside. When you're talking about a bolt with a thread on it, you'll name it after its outer width, which is the widest part of it. And in this case, this is an M4 bolt. Now, an M4 bolt will go into a hole which is just slightly smaller than it because the threads need to bite into something. If the hole is 4 millimeters in diameter, well, then this is just going to go straight in and then straight out again. So you want it very, very slightly smaller. And I'm sure there's a calculation or a table somewhere which tells you the exact inner size, but I don't know what it is. I generally just subtract by 0.5 millimeters. So that would be a 3.5 millimeter diameter or 1.75 millimeter radius. Let's put that down here. So the radius here we could have as 1.75. Okay, which made not much of a difference. Okay, but now we'll position it. Now I know that this width is going to be 10 millimeters, so I'm going to move this 5 millimeters in and 5 millimeters up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and it's not sticking true, but we want it to be, so we'll just increase the height of it. 12. Now notice that the cylinder doesn't have length, width and height, which the cubes did. That's because the cylinder is different. The cylinder doesn't have those dimensions really. I mean, what is the the length of it? You could say that length is the height, really depending what way it's pointing. But there's only a height and then there's a radius. There are other things like a cone, for example. A cone has actually got two radiuses. You've got the radius of the top one, which in a pointy cone is 0, and then you've got the radius of the bottom one. And you can decide which one is bigger than the other. It's really up to you. A sphere only has one measurement. What's its size? What's its radius? Okay, so now that we have one bolt hole and the center part, we can actually delete them. So I'm going to group these two together like that using the union, and again I'm going to call this holes, and then I can just subtract it. So we have a bolt hole and we've got a space that our electronics go into, but it's not really the electronics. Now in a lithophane what you really want is you're creating a light panel, and the problem with LEDs is that they're not panels, they're points. So the light points. If you have your picture too close to the LEDs, well then the points come through as just bright spots, and that's not what you want. So what I'm planning with mine is that there's a bit of space, as you can see in our little design here, and the LEDs will be above that space, and then the back space will be covered in tin foil, which will act as a reflective layer for the light. So the LEDs will actually be pointing inwards, shining the light inwards, and then the light will be bouncing off these and giving us a lot more of an even light across the picture itself. So now we need to talk about the LEDs. Where do they go? Okay. All right. Yeah, I just want to mention as well, like, this is FreeCAD is not really for designing, let's say, gaming models or stuff like that, because it's not really it's not really all that handy for that. It's handy for making models of things that you intend to be practical in purpose. You know, like let's say a door hinge, or you know, a drawer. I designed this in FreeCAD. But you wouldn't use it for designing, let's say, a model of an orc or a gnome or something like that. For that kind of thing, you'd use something else like Blender. You know, with Blender, you can do things like sculpting. You can't do that in FreeCAD. But I use this a lot because that's basically what I do. Is I make things, and I make things that are to be used for things, and not to be looked at, to be actually used. Now, in this case, like Lithophane actually is looked at, but from my perspective, it's an engineering problem. Like, how do I make it? Where do I put the screws? Where do I put the holes? That kind of stuff. You don't really think about that when you're model making, you know, because there aren't any. There's no screws in there. There's no holes, and you can just move things around. It's all about how does it look. But when I'm making something from an engineering point of view, it's more like, how is this stuff going to fit together? Is there enough space? Where did the electronics go? That kind of stuff. So now I need to think about the LEDs. I'm just going to grab an LED. I have a small bag of them right here, I think. Yeah, this is a small bag. All right. So I have a small bag of 3mm white LEDs. Okay. There we are. Small bag of 3mm white LEDs. And where did I put the ruler? 3mm refers to the size of the bulb itself, not the base. The base is very slightly bigger, but you can actually shave the base if you want. But the 3mm, knowing that it's 3mm is useful, because that lets you make a hole in this, which is exactly 3mm in size. Now, when I'm putting this in through the side of the wall, there is something important. Oops, I've lost my LED. There it is. Okay, LEDs are directional lights. They shine in a direction. Now there's an angle to it. It shines off in a particular angle, and in fact, this entire shed is lit by LEDs. But it's not like an incandescent bulb. An incandescent bulb, like the 100-watt bulbs you probably have littered around your house, they shine out light pretty much everywhere because of the way they work. They basically burn a filament, and the burning sends off the it's not really burning, but it sends off light in all directions. These are different. LEDs are different. They shine. There's a small kind of a cup that's mirrored, and the lights are bounced off that and outwards from the LED in a certain angle. We want to take advantage of that in this, to know that there is an angle that it comes out in. So we're going to point, instead of just, you can't just stick the LEDs in from the back and hope that it's going to work, because that just points the light upwards towards the photo. We need it pointing sidewards so that it will bounce off the tin foil that I want to put at the back. So that means here I want the LEDs sticking out of the side walls. Okay, so let's make a hole now. Create a cylinder, and that needs to be 3mm in diameter, because that's the size of my my LEDs. So these are small LEDs. They generally come in 3mm for very small, or 5mm, which is the ones you were probably more used to. So I'm just going to transform that, again using the same trick, and point it in that direction. So that's 3mm. Sorry, it's in the right direction now, but I want it to be, height is going to be, height is fine. It's a 10mm wall. You'll see. So if I just start moving that, and actually that transform thing, let's go back to that transform. You can actually use the arrows here if you want. You can just drag things up and down. Now I would usually use that just to move something roughly into shape, into the place where you want it. But then I'd go back and correct it very, very slightly. So in this case, it's after moving it up to, let's have a look at the placement, 46mm. all right, which is nearly right. So the height of this is 98, I think. Let's have a look at that again. 98. So we want that to be actually half that, which would be 49. 49. But it gives us the rough position of it. And now I can move it inwards. So we'll move it in the Y direction. There, that's about right. 5 millimeters. Remember, I made the width 12, but this back wall is 2, which means that this wall here is 10. So that's exactly halfway along there. Now we want to change the radius to 1.5 millimeters. Now we might want to introduce a little bit of margin because otherwise it may actually be a little bit too tight for the LED. Might want to. Now there's a number of different things you can think of here. Sorry, I'm back. I didn't even know you'd gone. All right. So might want, now the reason you might want margin here, if you want to be able to put the LED in and take it out, then you'll need very, very slightly larger space than exactly the size of the LED. Or if you trust your printer to be exactly right, you could have it the right size. What I would sometimes do depends on, now if I'm mass manufacturing, if I'm printing out loads and loads and loads of things, then I don't want to have to do any post-processing to what I printed, which means I want the whole to be right from the beginning. So I would introduce a very, very slight margin to the radius. So in this case, you might have it as 1.55, which would be very, very slightly bigger, or even 1.6. You might print this out once, try it and say, well, I want it very slightly bigger. But if you're printing this out in, and it's only going to be a once off, then you might just keep it at 1.5, and if there is a problem, you can get your drill out and just drill it very, very slightly bigger. So I'm going to leave this as 1.6. There's another thing to keep in mind. You can always glue the LEDs in if it's very slightly too big. You can just put some glue. It doesn't have to be super glue. Let me just show you what I have here. Right. Okay, so if I want something to stay where it is, I'll use a super glue. Okay, that's a super glue. And I use that on this. So that's, the photo is stuck in place, it's not coming out. If it does come out, something's broken. But if I want something to be movable, maybe gel-like, that I can just, I can pull it out if I need to, then I'll use something a bit more gel-like. So this, for example, is, it's like a gel glue. You can put it in and it will set after a while, but it's not a super glue, right? It's not going to go ultra hard. And even after it's set, it's still kind of rubbery. Like the electronics I have at the back here, I stuck in place using that gel, and it feels rubbery. And if I want, I can rip it off, and it won't do any damage to the plastic, so I can put it on again. So choice between glues. But a useful thing about it is that it is transparent, and so you can put an LED in it, and even if you get a little bit on the LED, it should be fine. Okay, so we've got this hole that's going all the way through. It's 3 millimeters, but the LED isn't that long. That's 10 millimeters wall, whereas the LED itself is, the bulb size of it is about 4 millimeters, and then just a tiny bit poking out the end. So we want a very, very small, the base of it is very slightly larger than 3 millimeters in diameter. So I'm going to make another copy of that cylinder, copy, paste, and increase the radius of it very slightly. Let's say to 2 millimeters. That's actually quite large. But if we look in closer now, you can see that they're both on top of each other. And you could say that represents, the inner one represents the bulb, and the outer one represents the base. Now, if I reduce the size of this, let's actually hide the outer frame, so we just have these cylinders, and I'm just going to make the outer size one smaller by how big? Let's check this again. 4 millimeters. So we'll just make it smaller, the height, by 4 millimeters. 1, 2, 3, 4. So that's where the bulb of the LED goes. and then the rest is for the base and the wires. All right, and we'll just group these together and group them together, union, and we'll call this LED bulb space, something like that. Okay, now unhide. I want to subtract that from this supercut. Now see this holes thing here. Here's where we get useful. This holes is actually a group. We did a union of that cylinder there and this space here. But a useful thing about a union is that it's not limited to just two things. We can put more things in it. So I'm going to take this entire bulb and stick it in there. So we take the LED and just drag it up to holes and let it go. And now it's in there. But you can see it's vanished here. That's because this thing doesn't realize, oh, I should recalculate now. So we'll just tell it to. There you go. And now we have a hole. But usefully, the hole has a diameter of 3.2 at the end and 4 on this side, which means that if we put an LED in, then the LED will stick at one point with just the edge of it poking out right here. Okay, so that's a perfect position for that, I think. Perfect. So the light from this is going to bounce towards the back, but it's also going to bounce slightly upwards and, you know, all sides. Now, so we would want a copy of that light bulb, of the LED bulb, there, 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 and there. So there's a number of ways we can do this. We can literally go through all this all over again, or we can copy that entire thing, or we can do another new thing, which is a clone. We can make a clone. So I'm just going to actually move this out again, and so Control Z will move it out again. It just undoes something, and we'll recalculate. Okay, so we have the LED space, and I'm going to now create a clone of it. I'm going to create 6 clones, and then we can move them around. So first off, I'll hide this, not interested in it. Now, the clone is in draft. So it's useful to just play around, have a look at all the different toolbars in this program and see what do they all do. Does anyone have any questions so far before I get on to this? If not, I'm just going to continue. So we have this, and the clone icon is that. It's a sheep. If I remember right, it actually used to be a stormtrooper from Star Wars, but now it's a sheep. And the sheep represents Dolly, which was the first large mammal that was cloned. So yeah, it's a bit of a joke. All right, so we'll just take that, and I'm going to clone it. Okay, and clone it again, and again. So we've got 3 clones, 4, 5. Okay, we only need 5 clones because the original is actually fine where it is. All right, so let's now go back to this cut and undo it, and you can see like it's all invisible because it's all basically in the same space. But we can now start actually moving these individual clones. So I'm going to right click on this and transform it. Right, okay, yeah, very slight problem here. Okay, now if I move this, you can see there's a very slight problem here, which is that it's actually cloned around position 0, 0, 0. Okay, so that means that if I move this, I now don't know exactly what numbers to give it in order to move it into an exact position where I want it. So to solve that, what we can do is take the original and move it. So we'll take the original and move it down. Let's see. So we'll take this position here and move it back down. So where it says Z49, we'll just change that to Z0. And the same with the other Z 0. We can forget about the y. The y is absolutely fine. But that's after moving all the clones now. So I'm going to need to make 6 clones. So the first one acts as a kind of a prototype, and it's just basically, this is what the thing looks like. That's a prototype in programming terms and in engineering terms is basically the original model of something. So if I just clone that again, I've got 6 clones. I can now hide the original because we're no longer interested in it. So we'll take the first clone and we'll move that one upwards to 49. Okay, and you can see that that's after moving. So that's in the right position. And then we'll take the second clone and we'll move that over on the far side to where it is there. Okay, so to do that, we'll first off rotate it, transform it, rotate it around. Wah, there we are. And I'm going to do this visually, so we'll just drag this all the way over here. And just drag it a little bit more. There we are, and it's just poking just right at the edge. Now, a useful thing about this, if you look at this translation increment and rotation increment, they are snapping into place at every millimeter step along the way. If I zoom in, you can see it a lot more obvious. So if I just drag a little bit, nothing happens. Drag a bit further, finally it snaps into position on the 1 millimeter grid. Okay. And that's useful to us because it means that we can visually move things around and get it generally in place, and in some cases we can get it exactly in place without needing to even look at the proper numbers. So that's around where we want it. We know that in the x dimension it's correct because it's just literally touching the end. We know that in the y dimension it's correct because we didn't change the y dimension. And the z dimension, which is what I'm working on here with the blue, we're going to make that into 49. So we'll get it generally in place, and then, oh, we were just slightly off, so down a bit, 49. So now we have that in place, and we have that in place. So we need the other 2, other 4. So let's do that. So we'll just move this one 90 degrees. Okay, so it's the right direction. We'll move that up to the top. Yeah, just there. Okay. Now, where does that go? Well, when I made these, I was just thinking about having them evenly around, so evenly around the around the shape of it. So it was kind of almost the same distance in all places. So if I want 2 along here, well then what we're going to do actually here is take this space and divide it by 3. Because if you think about it, 1 space, 2 spacer, 3. Okay, well then these 2 spacers is actually where the LEDs are going to go. So you take how many LEDs have you got, add 1 and divide that in, and that gives you the distance from this point here that you wanted. So this photograph is 120 wide, divide that by 3 and you get 40. So we'll add 40 onto the width here, which is 10 millimeters, and you get 50. Okay, so we'll just move that in to 50. You can see that. Okay, that looks right. And we'll just have a look from the other side, and yep, that's visible. Okay. And now we'll just move the next one up and do pretty much the same thing. Drag it up. All right, and that's going to be at position 90? 90. Did I get that last one wrong? Yeah, that's right. Okay. Now, so you can see that looks right. Yep. Okay. The other 2 at the bottom here, they're actually going to have the same x's and same x positions, but just facing the other direction. So we'll just move that like that. That's 90 degrees that way, and then we'll just move it in x by 50 millimeters. And then finally we've got this one here. I'm going to turn that one as well. Okay, Now I'm going to show you something in a moment that'll be very, very useful, and that goes into 90. Okay, so those two are in place, all the others are in place, and we're golden. Everything's perfect. Let's add all of them into the holes. So we'll just add that in there and recalculate, and you can see that we now have these holes. I don't like that grid being there. Let's get rid of that. How do you get rid of that? I don't see how to get rid of it. Anyway, all right. So the useful thing that I want to show you. Okay, I want to show you something interesting. The LEDs here are all pointing out the back, which means that if I have this case like that, you can have the LEDs poking out the sides. Don't really want that. What I want is for the LEDs to kind of, you know, be pointed inwards, but for their leads to come out the bottom, so I can put the electronics at the back. Okay, so to do that, what I'm going to do is introduce a space at the back next to every LED. And I could do that individually for the 6 that I've done here, but I can do something even better. I can affect just one. And because these are all clones of each other, they'll all be affected at the same time. So let's have a look. This original bulb, this is the original one that everything was cloned off. I'm just going to affect that single one, and you'll see that the rest are affected as well because they're clones of it. Okay, so let's just hide everything else, and we'll bring this bulb back. And now that draft thing is annoying me, so we'll just move that slightly into the middle. All right, I'm just going to add in a cube. So we'll go back into part and just add in a cube. I'm going to make the cube, how big was that? Oh, 3 meters. 4 in diameter. So this is going to have a height of, the cube is going to have a height of 4 to make it the same, and then it's going to have a width of, I don't know, well, I'm going to move it down first. Now if you look very carefully, you can just see that single line there. That's actually the LEDs. I'll move this down very slightly again so you can see. Okay, now I'm actually going to change the length of it so that it just matches that. In fact, maybe just a little bit more. There we are. Yep. And then change, and then just going to move it in Y until it is exactly halfway through the LED. And I could work out the proper Y for that, the width of that, but it's not actually important, and you'll see why in a moment. Okay, so let's now add that. So I'm just going to unhide everything here. All right. Now here's the magic. I'm going to take this and add it into our prototype for the LED bulb space. So we'll just stick that in there and then do a recalculation, and if I'm right, that space got added to all of our clones. Okay, that means that we can put an LED in the side and just bend the legs down so that they're at the back. Now, and then if I get the front of the frame, so I'll hide this again. If I get the front of the frame and stick it on that, if I make the back very slightly smaller, then I can make another case that goes right around it. So you won't see these legs, you won't see the side. And then I can glue it in place or screw it in place or whatever. And I can just put the electronics at the back. Okay. So that's printable. That's very easily printable. And that gives us something that we can just immediately stick LEDs into. Right. So I have in this, that's an hour and a half. I'm going to leave it at that. In the normal physical class, we'd be breaking for lunch right now, or sticking around and chatting. Now, let's see. Do you ever make a 2D model before making a 3D model? Yes, actually. So I'm just going to stop at this because I've shown you the basics, and I don't want to get any more advanced because we've only got half an hour left, and it'll get weird. So we'll just go into questions. If anyone else has questions, please ask. I can see there's a few of you watching. I don't know who's watching, but I can see a few of you there. Do you ever make a 2D model before making your 3D model? Now, yes, I do, but I need, like, it depends on what you mean by that. Now, I would sometimes make a 2D model and extrude it, which means that I would make I would pull it out into a 3D model. And I have an example. Yeah, I have an example behind me here. Just give me a moment. I don't remember if that's glued on or screwed on. Just a moment. Okay. All right. So the example I have is this little thing that I had on the wall that was holding a box. Now you can see it's a three-dimensional object. Let's just make this bigger. You can see that it's a three-dimensional object, but it's actually four two-dimensional objects glued together. Okay, with slots. You probably can't. There you are. So you can see the slots. So I designed this in such a way. I designed this in a two-dimensional shape with the slots, and just extruded it. Extruded the shape, the two-dimensional shape, by about 2 millimeters, and then printed them out and slotted them together into this three-dimensional shape here, which I use for holding drill bits. So yeah, I do. Yeah. And actually, the method that I used for this is actually the method that most CAD designers will use when they're building things. The method that I've described in this video is different. It's, in my opinion, it's a lot easier than this. But with two-dimensional drawings, which I'm guessing that you've actually done this in mechanical drawing or whatever they call it these days, technical drawing, I don't know what they call it. My guess is that you have done two-dimensional drawings and then extruded them. It really is just a different way of doing it. For me, I like putting things together, subtracting and stuff like that, depending on on what object I want to end up with. And generally that works best for me. But you'll find that most instructions online, like Fusion 360 instructions and stuff like that, they will go the opposite route, where they always start off with a two-dimensional face, which they'll then change in various ways and extrude and pull out different parts of it until you end up with the 3D model that you actually want. It's a different way of approaching it. In my case, I start off, it's almost like Rodin, if I remember right, it was Rodin that was a sculptor, was asked, how do you make a statue? And he said, I start off with a big block of stone, and then I look at that until I see the model that's inside it, or the statue that's inside it, and then I cut away all the bits that are not the model, and that's how you do it. Okay, and that's kind of what I'm doing. So I start off, for example, with in this case I started off with the frame, and then I cut away all the bits that are not the frame. Yeah, you do like the other way as well, like where you can start off with a block and you just say, well, actually I want a wheel on that, blah blah blah, and you add on to it. Yes, that's fine, but it's all generally the same thing: constructive solid geometry. So you're constructing something out of solids, out of cubes and cylinders and stuff like that. Whereas the AutoCAD and Fusion 360 ways of doing things are kind of the opposite, where you're starting off with a two-dimensional technical drawing, and then you're pulling it out of the 2 dimensions, and then you're extruding other different parts of it. In a lot of ways, it is actually a lot stronger. But for me, I think a lot of models are just so much easier to just, you know, I want a 2 by 3 by 4 cube, bam, there it is. You know, it really depends on what you're making. I'm not saying one is better, one is not. They're not. Neither of them are better. They're both just different ways of approaching the same thing. I have tried to get into my headspace, the 2-dimensional way of doing things, and I can do it, but I keep having to think about it. You know, to think like, well, next I move this here, and you know, it's just I don't like having to think about something before I do it. I like that with the 3D modeling. Like if I that for example, right? That's a drawer that I made with some spaces in it, and I made this. This is actually dynamic in that I can tell it. The design that I made for it, I can tell it how many spaces I want in it, X and Y. I don't know how I would do that in 2D drawing. No idea. But in CSG, you can just literally use, let's say, the matrix view, which I'll show in another class. And you can just say, like, I want it to be 2 by 3. You know, and you can use spreadsheets for that. I don't know how you do that in 2D. But I'm sure in 2D you could probably do something similar and then just extrude that outwards. This then has other things on it, like curves. The edges are curved, and the walls are specific distances, are specific widths. Now I know in 2D, in 2D mode and draft mode in this, for example, or in fact, let's go back to the FreeCAD there, because FreeCAD actually has 2 ways of doing 2D. It's got sketch and draft. So we've got draft, which is, you can see all these things here, they're 2-dimensional, right? So you've got 2-dimensional rectangles and arcs and stuff like that. But we also have Sketcher, which is pretty much the same. Like it's Sketcher is, I think, I don't know why they have 2 which are so very, very similar. But Sketcher is a lot closer to what you're talking about. You know, with Sketcher, for example, you could select this face and just decide I want to put something on that face, or I want to put something on that face and do whatever. And you have all these are rules, constraints, and these are the objects that you're making, like the lines and stuff like that. So you could say, for example, I want this line to be perpendicular to that other line, or this line should be, you know, parallel or equal, or stuff like that. They have a lot of rules, which is very, very good, because it's almost like the dynamic thing that I mentioned there, except that it's dynamic in a less exactly mathematical way. It's not like you're saying like this will be this plus this plus this minus 3. It's not. It's more like I want this to be long enough to be 2 millimeters from that, and then if you move that, it automatically changes. So you don't need to know the maths. That's actually a good point. If we go back to this little thing here. Now, if I was to build this in the CSG method, which is what we used in the frame here, you see this hypotenuse here. Now, I've done this before. I've done it in the proper CoderDojo classes, where I would actually figure out the length of something here based on Pythagorean theorem. And it's an absolute pain, you know, to figure that out, and then to figure out like the, you know, how to cut it in shape and stuff like that. It's a pain to do that, to figure out that, and just say it will be this long. How long? Well, we'll take the square root of this and subtract this and blah blah blah. No. In 2 dimensions, you just say, well, the outer line will go from this point to that point, and it will figure out the rest. So yeah, 2-dimensional drawings are sometimes better than the 3-dimensional method that I've mentioned here. Any other questions? Was that what you wanted to know? Right. I'm going to leave it at this. I think we have this class. I don't think it went on to very, very advanced features, and you have enough in this class to build something could be pretty cool. You could make a drawer. You could make you know, make a small model car if you want. But if you, anyone that hasn't used FreeCAD, and I'm pretty sure that's all of you, just go to freecadsweb.org, download it, and make a model, and send it to me. Send me the model. I'll print it out. You know, I've got all these printers lying idle, so send me the model that you come up with, and it has to be something that you made yourself. Don't download something from Thingiverse. You know, that's cheating. I want you to make something in FreeCAD, okay, and send it to me. Send me the FCSTD file, and I will print it out myself, and we'll talk about it in the next class. I don't know what we'll do in the next class, but you know, we might continue. Maybe I mentioned matrix earlier on, and matrix model, which could be useful. Sorry, Christmas is coming, for example. If we wanted to make a model Christmas tree, we might use the matrix view along with CSG to make a Christmas tree. So, and then we could do something weird like put LEDs into that, and be cool to print that out and have a number of different model Christmas trees to give out. That'd be fun. Or Christmas is far away, but Halloween is next door, so we could make a pumpkin. We can make a pumpkin out of all the orange filament I have here, and put LEDs in that to make it spooky. I don't know, give me some ideas, right? Put some ideas in, you know, below, or send them to me through Facebook or email or whatever you want to do, okay? At that, I am going to figure out how do I shut this off, and I'll say goodbye until next time. All right, bye. Are you sure you want to end your stream? Yes.